So thanks for the excellent discussions. I think in both groups. So as planned, like we can go in either order. Any of the group would like to go give a like a 10 minutes update on the discussions that took place. And please feel free to use the Google Doc or share it so that everybody can also.
I'd be happy to do the Google Doc, but I don't have it pulled up. Can someone pull it up, the one that we're being taken notes on, and share it?
I will do it. Hang on a second.
Yeah.
I have it right here.
Okay. So Eric and Jose can go. Yes.
Okay.
Yeah, Jose is going to speak for us, I think.
Okay. So
no, not yet.
Hold on. All right. So so some of the topics that we talked about, and actually I can't. Okay, thank you. Some of the points that we talked about in human-machine teaming. One issue was certain needs that we have, which were to extract the critical information. We're overloaded and bombarded with data. Most of it's unnecessary or not helpful for us. So as we're assessing the clinical histories or trying to get information about what's going on, it can be quite challenging. In terms of, the types of problems that we deal with, oftentimes have to deal with aspects of specimen adequacy. Some of that could be automated potentially, and so forth, and clinical diagnostic aids to help, like what is the prognosis, what is the right therapy. There was a lot of interest in the capacity to overlay images, even if they weren't perfectly registered. So for example, if two adjacent slides had been evaluated by a biomarker, can they be overlaid on top in a very simple way, despite the fact that they're not the exact same slide and so forth. Other aspects that were important were the ideas of when you're generating data sets for research, the aspects of annotation of images became very important. Many times the annotations are done by cheap labor, like residents or grad students or med students. And that was considered to be highly inadequate. So if you're training on bad data, you're quite problematic. And the other issue in terms of getting past data in historical data is that the terminologies change, and how are people talking about tumors now, and how they write up a report would be very different from even something from 6 years ago, which is not that long ago, but it might tend to bias the data, and so in terms of the research and development components, that was one important point. The other issue we talked about were how are pathologists communicating, and we were joking that there's pre-COVID and post-COVID. So right now there's a lot of email, there's Zooming or using Teams or Google Chats or whatever. But typically pathologists, if the center's small enough and they're next to each other, they'll just go and ask and walk over and so forth. And in terms of the what pathologists want, they definitely don't want their jobs to be replaced by let's say a Walmart of digital pathology or something like that, just putting scanners in places. But most pathologists get very excited once they start to understand the toolbox that is available once you start adopting these techniques. So emphasis on education and on what this could bring to pathology is very important, because it's currently lacking in all medical school and most residency curricula. So this is basically kind of summarizing up what we were talking about in this session.
Okay, I can stop sharing.
Anybody else wants to add anything, Eric?
No, I think that summarized it quite well. I mean, I think we had, basically a couple people on the pathology side and me and Raghu kind of chiming in here and there. So I think that was a pretty good summary of where we were. Yeah.
Okay. So might be Srini and Hamid, whoever wants to go and summarize.
Sure, I can do that. Let me share my screen.
Go ahead.
Yeah, so I think we started by discussing, and it's a mix. So I think there was some wonderful real-time note-taking by Amir and Carly and others who also were editing. But we started by discussing what are some of the challenges in the context of data management for pathology, data management broadly defined to include analytics and ML as well. So one of the first things that we heard from several of the pathologists in the room is getting data in the right format is a big challenge. And sometimes format can sort of come in the way in some senses. I think we talked about the fact that there's often a mix of structured, semi-structured, and unstructured data sources. Consolidating these diverse formats, and there are also various sources of noise that one has to accommodate. And we heard that from some of the talks that folks described. A big challenge that came up was scale issues. We are dealing with, in this context, very large scale images, but also large amounts of additional data, such as EHR data that may be relevant, that needs to be consolidated. We have to be able to understand some of these things at multi-scales, so multiple scale modeling and things like that. It was also pointed out that some of the newer technology, like BERT, for example, require a lot of resources in order to train these models. And so that is also an issue that one needs to think about. There were several questions about interface issues, both from the input side and the output side. In fact, several folks in the group talked about the fact that you ideally want something that interfaces nicely with the existing LIS system, so that it doesn't make life more difficult, and also enhances the chances of adapting these kinds of things, these kind of new technologies from the pathology space. So in this context, search and query interfaces can be improved. Multiple modes of interaction. I think several of the talks talked about this as well. And then several of them talked about the need for effective visualizations and dashboards, including ways in which you can percentile a particular case in connection with others that they have seen before, which may be helpful for various kinds of prognosis and diagnostic considerations. Several brought up, one of the challenges is community engagement. I mean, we need these communities to work together. So workshops like this is important. The fact that, it has to be a multi-institutional approach. It cannot be one institute in isolation. The other interesting thing that came up during some of these challenge discussions was, some of the constraints. And I think there are some well-defined guidelines in terms of certain kinds of analysis, especially if the patient is in the operation table, has to be accomplished within a period of something like 20 minutes, whereas for others, biopsies and others, there's a little more, you have more time to do some of these analysis. So in some senses, some of this complex decision-making has to happen in certain cases in a time-constrained manner. And so adaptability can be challenging in these kind of situations. So then the second sort of questions that we sort of focused on was, what are some of the ways we can address some of these? These are in no particular order. They don't exactly match the ones that we laid out there. We haven't had a chance to organize these. But some of the solutions we talked about include, attracting more talent, democratizing the ability for these tools to be used, not just in highly resourced hospitals and institutions, but also perhaps in rural hospitals, as well as in countries where maybe these facilities are not easily available. In the ML context, there were some discussion on different ways of presenting results. So I think several talks talked about TSNE. Are there ways in which this can be presented so that the pathologist understands exactly what is going on? I think several on the call or the discussion kept emphasizing that it needs to be a one-stop, easy-to-use visual dashboard, and we need effective mechanisms to reduce errors in diagnosis, and these kind of things have to be done in a friendly format and easy to utilize for pathologists. We talked about understanding and optimizing some of the different workflows for the different use cases. And one context we also discussed, in this context, how do BERT can be a massive model. So, how can we understand it? And then, of course, the issue of scale, how can you compute it at scale for some of the data that you're feeding into it? We talked very briefly about some natural forms of interaction, both from the input and, as I said above, from the output perspective. We thought about some ideas of addressing issues of scale. In particular, several folks, both in the talks earlier today as well as in the discussion group, brought up the fact that the ability to go back and understand when have we seen a similar thing before. Being able to do this kind of subspace level, feature level indexing is something that they would like better support for, which they don't have right now. There's some discussion on some of the new innovations that are being adopted within the field of pathology, and how some of those things could be integrated with answers to some of these solutions. And then there was a discussion related to resource management, especially in the context of democratization of these kind of tools and these kinds of innovations, urban versus rural, the idea of some kind of reduced order modeling or being more efficient about using your data, like Jose's talk touched on. And one idea that came up in the context of, especially if data sharing is involved across institutions, the idea of federated learning could be a useful solution. It is something that Google and others have been deploying in different contexts, and it seems like it might be a good use case scenario in the context of the kinds of things we're talking about here. So that is a rough summary of what we discussed. Hamid, anything to add, and others?
You said it all. For sophisticated systems like BERT and other big approaches, the fine tuning takes a little bit less effort than the actual training, and nobody expects that the pathologist go ahead and train it. So it comes pre-trained, and then perhaps we just fine tune it a little bit, which still, as it was mentioned, requires some resources and skills to do it.
Right. Anil, Jen, any of the others, have I missed anything that you guys mentioned?
I think it was all well summarized.
No, I think you covered it all. I think there was a really good discussion, and I think we've obviously were able to take some of the salient points from the talks this afternoon and discuss them in the context of all these issues that were identified. So very, very useful breakout session for me personally, and I'm sure for others.
So okay, I'll stop sharing at this point.
Yeah. So I think with this, again, we'd like to close today. Again, thanks to all the speakers, moderators, note takers, and we have an exciting program tomorrow. So it will follow the very similar format. We'll start with a keynote talk in the morning by Lee Cooper. Then we'll have a talk on explainable AI for anatomy and pathology from Chakra. Then we have a talk from Path AI on AI-based pathology for clinical stage biopharmaceutical drug development. And Muhammad Salama, AI promise to the practice of hematopathology from Mayo Clinic. Then we'll have a HPC talk, how do we take advantage of high performance computing for accelerating the deep learning with the large pathology WSI images. And then we'll have two breakout sessions tomorrow. One is focusing on how high performance computing can help the pathologist, and looking for outreach and industry connections. So those are the kind of the things what we have outlined for tomorrow. So Anil, if you'd like to give any final remarks, then we can close it.
Yeah, no, I think this was another exciting day of the workshop, and really enjoyed all the talks and the discussions, and already we've started to see some seeds of collaboration starting to occur between the participants and others. So let's continue that tomorrow, and get some rest, give your brain some rest, and come back tomorrow fully charged, ready to go. Tomorrow will be day 3 of this workshop. And again, thanks to our sponsors, the Midwest Big Data Hub, NSF, and our university, the Buckeyes. So thank you all,
Thank you.
and have a good evening, and see you tomorrow.